So good morning students. As you know, last time we discussed parallel plate capacitor with air and then after with dielectric medium. Now today we are going to discuss parallel plate capacitor with a dielectric slab. Look at students. PQ is a parallel plate capacitor in which both the plates are separated by distance small d. Okay. Now what we did, we inserted a dielectric slab. This is okay of thickness T. Actually, D is the separation between the plates. When we insert a dielectric slab of thickness T, in that condition, the thickness of air, okay, this plus that remains D minus T. So D minus T is the thickness of air, while T is the thickness of slab. Here we are having two types of medium, air and dielectric medium. So there will produce two types of electric field. E naught vector is the electric field of air and E vector is the electric field produced by dielectric. So two electric field will generate two types of potential. So what should be total potential between the plates? Total potential will equals to potential of slab plus potential of air. So total potential will be potential of slab plus potential of air. Now, as we did last time, what is the formula of potential? What is the relation between electric field and potential? V equals to E into D, where V is potential, E is electric field, and D is the separation between the plates. On account of this, for finding potential of slab, we require electric field of slab. Electric field of slab is E, and thickness of slab, T is the thickness of slab. So electric field of slab into thickness of slab will give the potential of slab, E into T. Now similarly, E naught is the electric field of air and D minus T is the thickness of air. So electric field into thickness, E naught into D minus T will give the potential of air. Okay. Now students, we did last time the ratio of electric field of free space to electric field of medium is said to be dielectric constant. Okay. So we'll make change. Okay. On account of this, E comes as E naught by K. Okay. So what we'll do, students? Instead, here I'm going to put E naught by K, that T as it is, E naught D minus C, that terms as it is. Equation number second. Okay. Now, students, we require E naught. E naught is the electric field of air. We did last time by Gauss theorem how much electric field generated by two charged plates, between two charged plates, as sigma by epsilon naught. And we know very well, sigma is called surface charge density. Charge lies on unit area, per unit area, having formula Q by A. Now, in this second equation, we'll take common as E naught. E naught is common, electric field. Remaining term will T upon K, and in that side D minus T. And we know very well what is the electric field of air. Okay, Q by A epsilon naught. Here I'm going to put Q by A epsilon naught. Okay, so we'll get potential as V equals to Q by A epsilon naught T upon K plus D minus T. Okay, but we have to find capacitance. How can we get capacitance? The formula of capacitance as given charge to a capacitor as Q equals to CV. But we have to find capacitance. For getting capacitance, it comes Q divided by V. C as it is, Q as it is, and potential we found as that entire term Q by A epsilon naught T upon K plus D minus T. Okay. So the value of this potential we'll put in equation number 4 here. C as it is, Q as it is, and what is potential? This entire term. When we put Q to Q, cancel out, and epsilon naught comes in multiplication. Okay, it become C equals to epsilon naught A, epsilon naught A. Okay, D minus T plus T upon K. So C equals to epsilon naught A, D minus T plus T upon K. This is capacitance of a parallel plate capacitor when we insert a dielectric slab of thickness T between the plates.